Hello everyone, I'm Jung Chol. OpenStack Administration Course Chapter 1 Introduction to OpenStack. Main topics. In this video, I will explain this kind of main topics. First will be introduction to cloud computing. Before I introduce OpenStack, I want to introduce the concept of cloud computing. And the second will be hypervisor types. Also, we need to understand the concept of hypervisor before we study OpenStack because hypervisor is a kind of core concept to implement OpenStack service. And after that, I will introduce OpenStack components. So first, what is cloud computing? So cloud computing means computing system to provide this kind of service. First, reading and writing data. Second, processing and analyze informations. And storing and managing this kind of data and information over the internet. So to access this kind of cloud computing, we need to use this kind of devices, smartphone, computer, or laptop, or tablet PC. And this kind of devices must be connected to internet to access this kind of clouding computing service. So normally we call this kind of the space is a cloud. So this kind of cloud can be used for data storage based on object and block storage. Here you can find if you are successful to implement this kind of cloud service based on many kinds of software platforms, then we can provide this kind of service to users or administrators such as network service, database service, servers or applications or web servers or mobile service as well. For this kind of clouding computing services, we have this kind of the main models like SaaS, PaaS, IaaS. So SaaS means software as a service. So this kind of software can be email or CRM or collaborate or ERP, and this kind of services can be consumed to end users. So normally SaaS focus on providing software. PaaS means the platform as a service. So this kind of platform can be application development, decision support, or web or streaming service. And this kind of service can be built on this PaaS, especially for application developers. IaaS means infrastructure as a service. And this kind of infrastructure can provide this kind of things: caching, records, networking, security, files or directories, or technical service or system management. And this kind of infrastructures or the services will be migrated to this infrastructure. So when you implement this kind of cloud service, you need to choose which models is our needs or our purpose. In case of OpenStack, this one belongs to IaaS, Azure Infrastructure as a Service. So let's check this kind of cloud service models, especially the definitions. So SaaS, software as a service. It means normally end user applications delivered this as a service rather than on-premises software. So here, on-premises software means it's installed, normally runs on computers on the premises. Here, premises mean normally the building of the person or specific person or specific organizations. So far, we use this kind of premises software as a traditional services. PaaS, the platform as a service. It means application platform or middleware as a service on which developers can build and deploy these custom applications. For example, Red Hat OpenShift is an example to provide this kind of platform as a service. IaaS infrastructure as a service. So this kind of IaaS can provide compute, storage, or IT infrastructure as a service rather than as dedicated capabilities by network architect. So here we can find the SaaS. So normally the SaaS layers can be used by the end users. PaaS layer can be used by application developers. IaaS can be used by network architects. So I already told you, if you want to implement IaaS based on OpenStack, you need the knowledge related to network service. So by IaaS, we can use this kind of service such as virtual machines or servers, network, storage, and load balancers. In case of the PaaS, can be provide database, web server, development tools, execution, runtime. In SaaS, example is email, CRM, virtual desktop communications, or gaming. To access this kind of IaaS or PaaS or SaaS, client need to access this service using thin client, terminal emulator, web browser, or mobile application, etc. So when we configure, when we implement this kind of service, always we have to think client, how can they access this kind of service as well. Cloud service models, so this is a kind of example for each layer. In case of the SaaS layer, will be like a Google applications or the Lotus or Yahoo Mail like this. PaaS can be Google Application Engine or Windows Azure or the VMware Cloud Foundry like this. In case of IaaS, the Amazon EC2 is an example of IaaS, while Google Cloud Storage or VMware service as well can become the example of IaaS. So to implement this kind of cloud service, we can divide or classify this kind of layers. So from the bottom, data center, the upper layers like application software. So in case of data center, we need the buildings, power cooling, or physical securities. We need to implement a networking layer. We need network infrastructure like switches or routers, firewalls by the Cisco or Netscreens. Servers, normally here servers mean physical servers, the rack, blade, and this kind of the physical servers can be provided by IBM or Dell or HP. Virtualizations, for the virtualization, we can use the hypervisors such as VMware ESX or MS Hyper-V. Operating system, normally operating system can be used to make virtual machines such as Windows or Linux or the Unix as well. And if we are successful to make this kind of virtual machine, then we can use the management, the softwares. We normally call this one orchestration layers. And after that, infrastructure software like a middleware or server layer applications such as MS SQL servers as a database, Google applications as well. Then in the highest layer, we can find application software such as MS Exchange like this. So here, this kind of applications delivering end user service. So end user will use this kind of applications. So if you check here from the bottom, especially the data center to virtualization, we can say this kind of things can belong to infrastructure as a service, and operating system management software, infrastructure software can belong to the platform as a service, and application software will be software as a service. So in here, there are four kinds of the models, cloud service models. On-premises means it's a traditional service model so far, and infrastructure and the platform and software. In case of the on-premises, if you are administrator, you need to manage all these kind of layers from networking to applications. But If we use just the infrastructure, then you need only to manage OS, middleware, runtime, data, applications. The others, like virtualizations, servers, storage, networking, will be managed by ISP or hosting companies or clouding companies. In case of platform only, you need to manage only two-layer applications and data. In case of the software, you don't need to manage any layer. All layer will be managed by clouding computing companies. Here, when we deploy this kind of cloud service, we can divide it into four models: private, hybrid, community, and public. Let's check one by one. So first, public cloud. So public cloud means whole computing infrastructure is located on the premises of cloud computing companies. And normally this kind of company focusing on offering the cloud service to end users. And this kind of location means separate from the customer. So customer only can access this kind of public cloud using the internet, and he has no physical control over the infrastructure. Only this kind of physical infrastructure can be managed by this kind of cloud computing companies. This kind of the public clouds use shared resources, so they do excel the mostly in performance. It means this one can support the high level performance, but are also most vulnerable to various attacks because this is a public, can be used by many users. Private cloud means using a cloud infrastructure as well, but this one can be done solely by one customer or one organizations. So it is not shared with others, but it is remotely located if the cloud is externally hosted. And the companies have option to choosing on-premise the private cloud as well. But in this case, you need to pay more expensive money to use this kind of private cloud service. They do have the physical control over the infrastructure because this is so private. So all physical infrastructure can be controlled by your customer or your organizations. The security and control level is highest while using a private network. So this kind of private cloud can be used by private network. So we can say this is the more secure service compared to public cloud service. Hybrid cloud. So this is a mixed service from private and public cloud. So according to your purpose and your situation, you can use or you can choose public or private cloud. So this hybrid cloud can support the flexibility. It means organizations can make use of various public and private cloud to utilize the advantages of both the deployment models. So anytime the depends on your situations, you can select public or private cloud service. Cloud busting, it means you can run at first time, you can run your application on private cloud, but later there are so many applications the private cloud cannot cover. In this case, bust it to public cloud to meet demand peak. Community cloud, it means implies an infrastructure that is shared between organizations, similar to private cloud, but this one is shared between some or several organizations, usually with the shared data. So this one can support shared data and data management the concerns. So for example, this kind of community cloud can be used by government of single country. If you check here, this is for example, this is can be a kind of Ministry of Education. This one can be a Ministry of the Tourism, and this is a Ministry of Agriculture. So only this and these three ministries will use this community cloud, and all data will be shared between these three ministries. So this kind of community cloud can be located both on and off the premises. So far, I explained the concept of clouding computing. So, on the cloud, we can provide this kind of compute to the service. So, this kind of service can provide a computer or the server. And this kind of computer or the server normally needed to install operating system according to depending on users the purpose. After making this kind of physical service into virtual environment. So in computing service, we will use the virtual environment, especially using virtualized operating system. For this kind of purpose, we can use hypervisors. So hypervisor can be used for virtual environment from physical servers. At first time, you need to have the physical servers, and using this kind of hypervisor, also you can install many kinds of virtual environments such as virtual operating systems. For this kind of purpose, we have to understand hypervisor. So, what is a hypervisor? Hypervisor means the logical platform to run multi-operating systems at the same time on host computer. We call normally this kind of operating system is a guest operating system, and the physical hardware, physical environment, if we install this kind of operating system, normally we call host operating system. So this kind of hypervisor is called virtual machine monitors. In hypervisor types, there are two types. According to the host operating system, we can divide two. Native or bare metal, we call normally type 1, and hosted, normally we call type 2. And the second, according to virtualization, we can divide into full virtualization and para virtualization. So let's check native and hosted or type 1 or type 2. In case of the native, normally this kind of native hypervisors run directly on the host hardware, not host operating system. In this case, we don't need to install host operating system. Only we need to this kind of hypervisor programs on the hardware. And this kind of native hypervisors can control the hardware and monitor guest operating systems. So Hyper-V or Zen VMware ESX is an example of this kind of native hypervisors. In contrast, hosted hypervisors can run within hosting operating system environment and with the hypervisor layer as a distinct second software level. It means host operating system is a first level, first the software level, but this hypervisor will be the second software level. And on this kind of hypervisor, we need to install guest operating system, and this kind of guest operating system is the third level on the hardware. VMware Workstation or KVM or Butterfax is the example of hosted. So if you see this picture, you will understand clearly the concept native and hosted. So type 1 as a native hardware, physical hardware, and of that only we need to install hypervisor. And on hypervisor, we can use many virtual machines, VM1 or VM2 or the other operating system as well. And this kind of virtual machines think they don't know they are virtual machines and they don't know each other as well. And type 2, first time hardware, and of that we need to install the host operating system. This kind of host operating system kernel especially must support this kind of hypervisors. Using hypervisors, we can install many kinds of virtual machines, and each virtual machines can have this kind of user space and kernel as well, and they know they are virtual machines. For this kind of pose, I already told you we can use this kind of software like KVM, Butterfax, ButterPC, and parallel BlueStacks. Full virtualizations. So in this case, normally full virtualizations, the hardware such as CPU, memory, hard disk, or NIC will be virtualized fully by this full virtualization. So this virtualization allows multiple guest operating systems like Windows, Linux, or Unix to run simultaneously on host computer, and they don't know they are virtual machines each other. This kind of guesting operating system can access the hardware to use through hypervisors directly. So in this case, we don't need to modify this kind of guest operating system. For this kind of purpose, or for this kind of support, the CPU must support virtualization technology such as Intel V and AMD V as well. So VMware ESX Microsoft Hyper-V is an example of full virtualization. Para-virtualizations, hardware will be virtualized, but not fully, but only partially. So this kind of the guest operating system needed to transfer the command to hypervisors. Then hypervisors can access the hardware to controller. In this case, guest operating system cannot access this kind of hardware directly. So this kind of guest operating system, especially the kernel, need to be modified to use hypercall. This kind of hypercall normally can be used to transfer kernel commands from guest operating system to hypervisors. Then hypervisors will transfer this command to hardwares. So this kind of para-virtualization can be used for open source operating systems such as Linux, because I already told you this kind of para-virtualization needed to modify the kernel. To modify kernel, we have to know the source code of the kernel, but the operating system like Windows does not provide source code of the kernel, so we cannot modify the kernel. So Gen can be an example of para-virtualizations. So if we check here, in case of the full virtualizations, OS partition can be divided, separated between the other operating systems. And this kind of the operating system can access the hardware directly through this kind of hypervisors. But in case of para-virtualization, each operating system has their own partition like this, but each operating system has this kind of hypervisor interface and the driver channel. And this kind of driver channel can be connected to channel interface on driver partitions. And this kind of device drivers can be connected to physical hardware through hypervisors. So according to your situation, you can select full virtualization or para-virtualization. Open source cloud platforms. There are several open source cloud platforms we want to use, especially these four platforms so popular among many users in the world: OpenStack and CloudStack and OpenNebula and Eucalyptus. Especially here in this course, I will focus on OpenStack. If you are interested with the other cloud platforms such as CloudStack or OpenNebula or Eucalyptus, you need to install and study this kind of platforms by yourself or using many resources. Now the CloudStack also acquired by the Apache Foundations, and this one is managed by Apache Foundation nowadays. So here, OpenStack, the project launched by the NASA and the Rex phase in 2010. And in case of the OpenStack, can support this kind of hypervisors, KVM, Gen, QEMU, VMware, ESX, or Hyper-V as well. So if you want to know more information, you need to visit this website, openstack.org. CloudStack can provide GUI management console, multi-hypervisors, firewalls, and load balancers. So this one also can support the hypervisors such as KVM, Gen Server, VMware, ESXi. And I already told you this one acquired by Apache Foundation in 2015. So if you want to get more information about CloudStack, you have to visit this website, cloudstack.apache.org. OpenNebula, this is a free and open source software released in 2008, and OpenNebula also can support KVM, Gen, VMware, ESXi, Hyper-V. So you need to visit this website, opennebula.org, to get more information. eCarlitus, this is also open source project started by the UC Santa Barbara University in 2008, and this is also free and open source computer software. Especially eCarlitus is used for building Amazon Web Services. This one also can support the hypervisors KVM, Gen, VMware, EXI as well. Please visit this website eCarlitus.com to get more information about these cloud platforms. So as I told you, hypervisors on each cloud platforms. So OpenStack can support KVM, Cube, or Gen, the other hypervisors as well. CloudStack also can support KVM, the VMware, or Gen, OpenNebula as well, KVM, VMware, EXS Gen. eCarlitus also support this kind of hypervisors like OpenStack and CloudStack as well. Here, let's check the meaning or concept of OpenStack. So what is OpenStack? So OpenStack is a free and open source cloud computing software the platform. Normally, this kind of OpenStack is users primarily deploy this OpenStack as an infrastructure as a service from three cloud computing models. And this technology consists of group of the integrated project. This kind of project will control fulls of the processing, storage, and networking resources. So this open source at first time is designed and architected to replicate public cloud infrastructure such as Amazon AWS. OpenStack.org released under the terms of the Apache license. So I already told you the concept of the OpenStack. So OpenStack is a clouding operating system. And this operating system controls large pools of compute, storage, and networking resources. So here you can find compute, networking, and storage services through a data center to control this kind of compute, networking, storage. Then we can use this kind of OpenStack dashboard. And this dashboard will give the administrators control while empowering their users to provision resources through web interfaces. So your application will be provided to end users using this kind of API. And this kind of OpenStack shared service must be based on this kind of standard hardware like physical servers. Cloud computing platform normally sits above the virtual data center and provides both control plane and resource access to the virtualized data centers. OpenStack as a cloud computing platforms that manages virtualized resources such as virtual machines exported by a hypervisor, network overlays created by software-defined network devices, and volumes exported by virtual storage arrays. So here we can find this kind of virtual resources. OpenStack normally take these data center resources and normally to automate this kind of all the resources and orchestrate them so they can be accessed on demand and be scaled up and down as needed, turning these resources into consumable services. So this kind of users or administrators can access this kind of virtualized resources through this kind of OpenStack service. I told you OpenStack had several project normally we call OpenStack components. So at first time from the beginning here, dashboard is a project name is Horizon and the compute is Nova. and networking Neutrons. So for the storage service, OpenStack now providing the Swift and the Cinder. The Swift is a object the storage, and the Cinder is a block storage. For the shared service, the Keystone for especially identity service. Identity means normally here authentication and authorization services. Glance as an image service. Normally here, Glance will stores and retrieves virtual machine normally. Disk images were template. Ceilometer's telemetry service is normally the focusing on the monitoring and the metering the OpenStack cloud. Ceilometers as a telemetry service will focus on the monitoring and the meters the OpenStack cloud. Except this kind of the component, there are the three kinds of higher level services such as the Heat, Trove, Sahara. Heat normally focusing on the orchestrate multiple the composite cloud application. Trove normally providing especially database service, and the Sahara as a data processing service focusing on the provision on the scaling Hadoop cluster service. So here in the previous page, I described this kind of OpenStack component. Then here we can divide like this. So it's a compute service, is a NOVA, the project name, as a storage three kinds, Cinder, Glance, and Swift. For networking, we can use the Neutron. And for the monitoring service, Ceilometers and data processing, we can use Sahara, especially for Hadoop cluster service. And the orchestrations, we can use the Heat. And shared service as well. For identity service, we use the Keystone and the dashboard Horizon to access this kind of OpenStack service using web interface. And this kind of all OpenStack services component will be implemented based on this kind of operating system. OpenStack the release history. OpenStack released a first time 2010 October. In this time, the release name was the Austin. According to the OpenStack Foundation, nowadays per 6 months, new OpenStack version will be released. So at first time in 2010, only there were two component code names like Nova and Swift, but now the 2015, here maybe October will be around the 16, this kind of code names. In this course, I will focus on this one, Juno, October 2014. But if I'm possible, I want to add the ironic as well. Then I will focus on Kilo in 2015 as well. So let's check the OpenStack architecture. So this kind of OpenStack is made of individual autonomous components. In the previous page, I already showed this kind of component. And all of these components are designed to scale out to accommodate throughput and availability. So according to your purpose or the situation, anytime you can add or delete this kind of service. This is a scale out. And this is OpenStack is considered more framework. So this all the architectures relies on the drivers and the plugins. So per each component needed to use this kind of drivers for the plugins. And this OpenStack is written in the Python and is heavily dependent on Linux sectors. So this is an example of the architecture, especially OpenStack Kilo in 2015. So at first time here, for the authentication service Keystone and the monitoring service Ceilometer and provide the user interface is a Horizon. And for Sahara, for the Hadoop cluster service, Heat for orchestrations, the Trove for database, Cinder and the Swift for storage service. Nova, especially the providing is the instances, virtual instances, and the Glance, especially providing this kind of images for the template of the virtual machines, and the Neutron to provide the networking, and the ironic in Kilo is provide the PX in networks. So using this kind of internet services, we can provide the applications to users, and this kind of Keystone, Ceilometer, Horizon will control this kind of services. So now let's check one by one per each this kind of component. Dashboard, the project name is Horizon. So this one provides web-based self-service portal to interact with the underlying OpenStack services. So to control all OpenStack services, we need to access this kind of dashboard. And if you are successful to access this kind of dashboard, you can launch the instances, like a virtual instances, assign IP address for networking, and configuring access controls. So if you want to use this dashboard, you need to this package OpenStack dashboard. Compute is Nova. Nova normally will focus on the provisioning and managing large networks, especially virtual machines, to offer on-demand computing resources. So if the client demands this kind of computing service, then at first time we need to create this kind of virtual machines. So Nova will be responsible for creating this kind of virtual machines. So this kind of the compute resources are accessible via APIs, especially for developers, and via web interfaces for administrators and users. So it means now the OpenStack can provide two kind of interfaces for access, API and web interface. And this kind of the Nova can manage different types of hypervisors via drivers. I told you normally this OpenStack component will use their own driver, such as KVM or VMware ESX. So if you want to implement this Nova, then you need to install this package OpenStack Nova. Networking service, the Neutron. This one is a programmable, scalable, and API-driven system for managing networks and IP addresses to running instances. If we are successful to create virtual machines on Nova, then this kind of running instances need this kind of network information. In this case, we have used Neutron. So Neutron can manage IP addresses to allow for dedicated static IP or DHCP, or software-defined networking, in short SDN, intrusion detection system, in short the IDS, load balancing, firewalls, virtual private networks. So for this kind of purpose, we can use Open vSwitch by Red Hat, or Cisco, VMware, NSX, or etc. So if you want to use this Neutron, then you need to install OpenStack Neutron package. Swift, normally for object storage. This is a highly available and distributed, eventually consistent object storage. So this is a Swift provide a mechanism for storing and retrieving arbitrary unstructured data, even if your structure is not structured, but no problem to use by Swift. This will also provide the object based on interface via HTTP, and this kind of HTTP based on API. So organizations can use the Swift, this kind of store lots of data efficiently, safely, and cheaply using this kind of Swift service. For example, Amazon Simple Storage Service is an example of this kind of object storage. So if we want to implement or use this Swift service, then you need to install this package OpenStack Swift. Block storage Cinder. This will manage the creation, attaching, and detaching of the block devices like a hard disk. Two instances running within OpenStack. One instance like a virtual machine is running, but this virtual machine needs more block storages. Then in this case, we can use the Cinder service. So block storage volumes are fully integrated into OpenStack compute instances, because I already told you Nova will be responsible for creating this kind of compute instances, and this dashboard allowing for cloud users to manage their own storage need. If they need more storage, then they can extend their storage service using dashboard. For this kind of purpose, we can use Red Hat storage, and this storage can use this kind of file system cluster FS for block storage service. Amazon Elastic Block Store also, this is a kind of example service to use block storage. So to implement the Cinder, we need to install OpenStack Cinder package. Keystone as an identity service. So this one provides the central directory of users mapped to the OpenStack services they can access. This is, I already told you, it's an authentication and authorization system across the cloud operating system. This one can support the multiple forms for authentication like username and password credentials, or token-based systems, or AWS-style logins. All OpenStack services rely on Keystone. Why? To verify users' requests. So Keystone will be only responsible for all users the verification on authentication and authorizations. So to use this Keystone service, we need to install this package OpenStack Keystone. Glance as an image service. This one will provide the discovery, registration, and delivery services for disk and server images and the template. So if you are successful to implement the OpenStack, then maybe users will request this kind of operating system, especially virtual machines. And to create this kind of virtual machine, we need to prepare for this kind of images. So this kind of stored images can be used as a template to get new servers up and running quickly and more consistently. This glance also be used to store and catalog unlimited number of the backup. So glance can be used for backup service. As to use this glance, you need to install the package OpenStack Glance. Ceilometer. So this service will aggregate the usage and the performance data across the service deployed. So normally the focusing on meters of OpenStack Cloud for billing, benchmarking, scalability, and statistical purpose. So using this service, we will acknowledge then users use what kind of our resources, how long or how much to monitor and meter this service. Then maybe this kind of company will issue the billing invoices to end users. So this Ceilometer allows the cloud operators to view metrics globally by individual deployed resources. To use the Ceilometer service, you need to install the package OpenStack Ceilometer. Heat as an orchestration service. This is a template-driven engine that allows application developers to describe and automate the deployment of infrastructures. So Heat can be used especially for application developers. Also, this Heat can perform the auto-scaling of the certain infrastructure elements through integration with a telemetry service. So if you want to use the Heat, then you install the package OpenStack Heat Engine. Trove. So this allows users to quickly and easily utilize the features of relational databases designed to run entirely in OpenStack. In OpenStack, users anytime can use this kind of relational database service by Trove. So when users use this kind of relational database service, this one must not have the burden of handling complex administrative tasks. Cloud users and database administrators can provision and manage multiple database instances as needed. To use Trove, you need to install package OpenStack Trove. Sahara as a data processing service. So Sahara provides the capabilities to provision and scale, especially Hadoop clusters in OpenStack. So in chapter 12, I will explain how to use the Hadoop on OpenStack. By specifying the parameters like Hadoop version, cluster topology, one knows the hardware details, we can use the Sahara service. So this one, Apache Hadoop cluster management on OpenStack. You need to install the package OpenStack Sahara to use this service. Ironic, this is a bare metal provisioning. This one is added in the keynote in 2015. So this is an unintegrated OpenStack program which aims to provision bare metal machines instead of virtual machines. So far, I just explained all this kind of the OpenStack component only use the virtual machines, but using Irony, we can use bare metal machines. So this one is forked from the Nova bare metal drivers. So Irony will use PXE and IPMI in concert to provision and turn on or off this kind of machines. If you want to install this one, if you want to use Ironic service, then you need to install package OpenStack Ironic API. So far, I explained each the components of OpenStack. Now, it's time to install this kind of OpenStack. There are so many ways we can install this kind of OpenStack according to our needs and situation. So here, I want to recommend especially 3 nodes for controller node, network node, and compute node. Each this kind of node has their own service like this. For example, the controller node can provide the basic service such as identity, image, compute, networking, dashboard. According to your situation, also this controller node can provide block storage, object storage, database, and orchestration and telemetry as well. In networking node, only this one will focus on networking. In this case, this kind of networking node needed to have network interfaces like this for management and instance tunnels and external connections. In case of the compute, this one basic service is compute like a Nova and networking, and as an optional we can use the telemetry service. In this case, the computer also need to have these two kinds of network interfaces for management and instance. Instance means virtual machines. Instance tunnels like this. Then all this one will be connected to use the management network interfaces. Deploying the OpenStack. So if you are interested with the OpenStack, how to install what kind of operating system, especially the Linux, then you can use this one, Red Hat, SUSE, or Ubuntu. If you are interested in the package deploys, then Mirantis or the Keystone or Lex basis. If you are interested with especially the configuration management tools for OpenStack, then I recommend the Chef and Puppet Labs. So if you are interested with this kind of information, then you need to visit this kind of website. So for this course, I will set up this kind of OpenStack Lab using controller, compute, and networking node. So in my case, I will use the 3 node: controller, compute, networking, and these 3 nodes will be installed on the VMware Orchestration 10, and all this operating system will be CentOS 7.1. And each this kind of node will have this kind of information: host name and the operating system, IP address, and storage. In case of IP address, according to the situation, I will add 2 more interfaces for each node, and the storage as well. Now at first time I will use the compute here 60 GB, but later if I need more storage, then I will add especially to controller node. So far I explained about introduction to OpenStack. So in chapter 1 I explained the clouding computing definitions, and the second cloud service models such as SaaS, PaaS, or IaaS. Also, with the cloud service model, I already explained the concept of hypervisors. And the last topic was the OpenStack components, especially in 2014 in Juno. and 2015 in kilo. So there are 11 components, and also I explain each this kind of component one by one. What next chapter? What next chapter? Maybe in chapter 2 you will study installation requirement and installing OpenStack using Packstack and using OpenStack. The last topic will be removing Packstack deployment. Thanks for watching this video. God bless you and see you in next chapter.